Yeah, nice to be here. I learned yesterday that I was on the first DEF CON ever, and it took me quite a while to get up here. So it's nice to be here today to speak about my current project, which is Kuberay, Liferay in the cloud for Kubernetes. So I have to say up front, this will be not a Kubernetes 101 talk, so I will not talk about basics, but how to use this technology really in a real-world project. So I expect that you have a little bit of knowledge about Kubernetes in general and how you configure a system inside of the Kubernetes cluster, because this will be more in-depth talk. In general, the talk is split in three different sections. So the first section will be really about the product, so what did we build. The second section is look back over the last 2 years. What did we do with those technology? How did it really help us? And what did happen also in the tech world around our project. And the last bit will be really about how do we use Kubernetes, where do we store our config files, and yeah, how we are using this technology in our project. So let me start with the what. What did we build? A marketing service platform. So some of you may ask yourself, what is a marketing service platform? So everything is about marketing and campaigning. So we have a tool to integrate really campaign planning, so you're able to plan your marketing campaign, you're able to brief digital assets, you're able to review digital assets in the platform, you're able to manage and maintain these digital assets. Also, you're able to do sourcing and commerce. So this means if you want to have, for example, nice marks which need to be distributed to different locations where you need them, for example, you have stores across the world or things like that, then you are able to, on the one hand, to design, on the other hand, order, and also to distribute and deliver those items to your shops. And our platform is also providing KPI and analytics for the B2B clients which are using the platform, where you can really see where do you spend your marketing budgets, how do you use your budget, how many different versions of an asset, for example, do you produce, because every iteration costs you money. And how to develop, operate, and maintain such a platform, which is really used by 150 different brands, which are very, very known. So every one of you know those brands which are using the platform. Every brand who's using the platform has an individual branding, so they're really, it looks like it's one of their internal systems for them. Also, we have up to 600 parallel users which are using the platform in 25 countries across the world. So in every given time, someone may be online on the platform, so we can't really afford a major downtime because someone across the world will always use the platform to work with it. So we have chosen to use Kubernetes together with Liferay. We also are one of the first projects in Europe who implemented commerce. We're using, from a technology perspective, Terraform and Customize. I will talk a little bit about those technologies later. And we're running on AWS. So Liferay, the cloud with Kubernetes, which is really cool and a really flexible way to manage your infrastructure and to really react quickly on changes around your project. So for example, we're tackling common challenges with the platform. For example, config management and transparency. If you think where today configurations are stored, this is different in different places. For example, really on the Liferay node, for example, how many memory we're using, which kind of storage we're using. Also on the network level, really. For example, in the switches, how are our networks configured? How is an IP setting set? Which routes are configured? Which ports are open? So we have configuration distributed across the whole enterprise model. And we are centralizing this with our platform. So all the configurations are really stored in the Bitbucket repository. So everyone, even the people without really access to the infrastructure, are able to really see the configurations and check what's active and how is it built in the different environments, which is really cool. also this transparency really helps us in the communication between, for example, developers and operations. Because in a common enterprise, you have 2 or 3 different teams who are responsible for running an application, right? For example, the development team usually develops the platform, but also knows very well how the application should be configured and what is needed in the different stages. And then you have service management team who know already less of the one system because they have already to support 5, 6, 7 or 10 systems. And then you have usually the network administrators who even know less than the application developers about the system. And by storing everything in configuration files, those guys have the same view to the platform as every developer, which is really good and really easy. And we do not need complex scripts which need to be executed or handed over to the operations team to really install the platform. Because it's standardized, and it's standardized across projects. So it's not only for Liferay, it's also for cloud native project. If you have a strict root application, it doesn't matter because it's exactly the same process for all of those different tools and applications or projects you're running. So benefits I have seen over the last 2 years, the most important for me is really fast reaction on business requirements and changes. So we are able to react fastly if we need to change the environment, if we need to do infrastructure update, if we need new environments. Whatever came up for us, it was really easy to tackle because this technology is very flexible regarding infrastructure management. As well, deployment time and complexity. Because everyone in our team, so we are not splitted, so we have one DevOps team, or multiple DevOps teams running on the project. Everyone in our team is able to deploy the application. And he really knows how to use it, and you have only to learn one technology to also replicate this across different projects. And that's much easier because whoever needs to, for example, implement a single sign-on solution also writes the configuration for them. So the developer who is installing this into a QA or a production environment doesn't necessarily need to know the 100% details of what to configure, which is really nice. And also we're getting high availability out of the box. Because with Kubernetes, all nodes are in the cluster. If we have a hardware failout, our instance gets just shifted to another node and it gets rebooted, so it will be available. And with and we're also getting no downtime deployments. Because Kubernetes is managing this for us. We have scripts running who are checking if the server is available and only if the system is up. So for example, if LCS is active and the license is there inside of the cluster node, then the users get on it. Our journey began on the 1st of May 2018 with this technology, where we started, of course, with Kicker. But there were no real Kubernetes services available. So neither AWS had a Kubernetes managed service, nor Azure, and also Liferay DXP Cloud was not there. So we really started with bare metal, and we had to do the decision between, do we use the native AWS technologies, or do we set on an open standard which seemed to really emerge. And this was the case. We started to build Kubernetes on EC2. So if any one of you wants to do the Kubernetes administrator certification, you need to know Kubernetes the hard way. At this time, we did it exactly that way. And as you have seen, 35 days later, Amazon was giving out the Elastic Kubernetes service, but at this time we already went live with our system. Whereas live meant that we need to build up a whole project environment like Confluence, Jira, Bitbucket, Jenkins, and as well 3 live environments. So after that, at some point, EKS, so the Elastic Kubernetes service, was also released in the EU, where we could finally start to use it. But our client decided also, we have now this MVP running, we have now this new platform, but we want to go on a roadshow with that. So we want to really show our clients what will be possible if the product is fully live. So we needed a system which is highly available, which is not interrupted by dev deployments, which is not interrupted by QA activities. So we decided to set up a new system. And if you're in a classical environment, and depending on the processes you have internally, I would say that's usually roughly 4 days of time, but it may be also up to weeks, depending again what processes you have to follow. So we did a setup from zero to reachability from the outside world by a public URL in 3 hours, which is really, really, really fast and already shows how this technology enables us to really do infrastructure deployments. After that, our team went in a 3-week cycle and we were pushing out functionalities every 3rd week to the platform. Then we wanted to use Liferay 7.1 because we wanted to use some features in Liferay 7.1, for example, the advanced forms and also the fragments. So what to do? We need to, on the one hand, really push the functionalities of the platform, and on the other hand, we want to migrate to 7.1, which is usually a stop in the development activities. So we decided to split up our code base and also our development team. One team was focused on 7.1, so we did the Liferay 7.1 proof of concept to check what's needed, how complex is integration, and the most of the team was working really in pushing features towards the productive environment. In the next sprint then we did the actual migration, so we migrated all our modules, the themes and everything around to 7.1, but the smaller part of the team was still pushing features. And then we went live with this platform. So what we can see here is, again, we set up just a different system, and it was really quick and easy to work on different work streams. In parallel, we had to do infrastructure migration into EKS, because the driver for us was that there's a Kubernetes privilege escalation. So we had to migrate our whole infrastructure to a new Kubernetes cluster and also to a new infrastructure, which was merely really setting up the Kubernetes cluster, pushing down all the nodes and rebooting them inside of another cluster, and we shifted our DNS entries, which was also really, really easy. And we could work on a new cluster all the time, where we all the time fully had backup available. So then we went again back to a 3-week cycle, continuous deploying features and functionalities into the platform. So in the beginning of the year now, our client decided we want to have 3 major releases, because we're back from the platform stage. We're now more looking on the product like an office suite, for example, where you can buy in certain functionalities and can use certain functionalities in the platform. So we decided to integrate Liferay Commerce, build a planning tool very similar to Microsoft Project, and also, of course, still pushing the product from the core functionalities forward. So we again set up 3 different development teams this time, 3 different environments, which we are in parallel working to those 3 release dates. So we synchronized the code. We did a very early integration, so every change for Liferay Commerce and also the change of the other features which were developed. And then we went live with Liferay Commerce, which was then our main branch to develop new features in the platform. And also we went live some weeks ago with campaign planning functionality. And then we went back to the 3-week cycle, which is the case what we're doing today. So this was our journey in 522 days. And for me, really looking back, was really impressive what we did regarding infrastructure shifts over those time. Because usually you do set up one infrastructure and then you stick to it. And we had to shift several times our infrastructure for several reasons. And this was really, really easy with the Kubernetes below Liferay. And we can also see this in the Liferay DXP Cloud, because from the technology stack, this is very, very similar. So how did we build all these things together? So as you can see, we of course first needed to build a Liferay image to get our Liferay installed inside Kubernetes. We also have different repositories for the different configurations, like for dev, for production, and our base configurations. Both of these things are built by Jenkins. So Jenkins is building our code, is pushing the Liferay Docker image to a repository, and as soon there's a change on the dev, prod, or UAT environment, Jenkins is also building our Kubernetes configurations and push them to the corresponding cluster. As you can see, we have two different Kubernetes clusters running, one for production and one for non-production, whereas the non-production cluster is also executing all the development environment tools and like Jira and Confluence and Jenkins itself. And the production cluster is more or less only executing Liferay and some corresponding services for messaging and things like that. So let's talk a little bit about the Liferay images. We decided over time to use three different Docker images. The reason is build time on the one hand, and on the other hand, changing of the contents. Because the base image, for example, is really, or it's changing very rarely. Like you do an OS update every second or every third month, maybe once in a half a year. And also we have certificates inside of this image, which are used across the different environments. We are creating the Liferay user, and more importantly, we install additional tools into the image. For example, in this case, ImageMagick for image processing. The second one is now Liferay bundle. Reason why we extracted that is to download the Liferay bundle, to unpack it, takes up to half an hour. So, which means if you want to have a quick turnaround between pushing code and deploying to dev, that's killing this process completely. So it extends, of course, the base image, and we're unzipping the Liferay bundle inside of this image. And the third one is really our modules image. There we build our OSGI modules, we build our themes. It's extending the Liferay bundle, and we are unpacking all of the modules inside of this image, and that's the one who gets constantly deployed across all the different environments. So let's take a look onto the configurations. For the Kubernetes cluster, we are using Kustomize. Kustomize is a tool which helps you to not replicate your configuration over and over. Because in a classical environment, you would take the Kubernetes configurations and would copy and paste the exact configuration files across the different environments. So in dev, in production, in UAT, it would be 100% the same configurations with some changes. But those changes are very small, like about 20%. So Kustomize does help you to define one base, which is of course also in a Git repository, and then only change per environment those values you really need. So here we have the customization YAML, which is the core configuration file for Kustomize. We define which Kubernetes resources we want to use. And we're also defining those configurations which are used across the different environments. And what you can already see is that we are injecting our configuration files to runtime. So they are not built into the container image. Then here we have the full-blown stateful set, where, for example, we set the replicas. Also, we define the image which to use, and also the volumes mounts. Here you can see that we are all of the configuration files are really injected into the container as runtime. So, for example, Tomcat configurations, OSGI configurations, portal stage properties, all of those are stored inside of the Kubernetes cluster, are fully transparent, and are used in those environments where they need it.
If we take now a look onto the ingress, where the ingress is the definition of which URL should point to our Liferay instance, you can see here that we're defining on the one hand the URL and on the other hand the secret which is used to terminate SSL in our cluster. So moving now on to the dev configurations, we have again the customization XML YAML, which defines the environment-specific properties. For example, we are setting the namespace and we are referring to the base customization file to use it. So if Jenkins goes and builds a customization, it takes those files, downloads the base files, and generates all the Kubernetes configurations we need, which then get deployed to the cluster. So here we are, for example, defining a so-called patch JSON, which gets loaded and replaces some values inside of the ingress. And also we are again defining the config map generator, which now extends the OSGI configurations we have defined in the base image, and also just adds the OSGI configurations which are specific for this environment. Here we're seeing ingress patch JSON, where we're replacing, for example, the host name for the ingress and also the TLS file, which contains the secret to terminate SSL in our cluster. Also, the patch for the STS, typical values to set here is the number of Liferay nodes we really want inside of the cluster, and also the maximum resources one of our cluster nodes should use. And for production, it's very similar. We again have a customize file, and now we are setting the production host URL and also the production TLS. As well for the stateful set, we are setting the amounts of nodes. As you can see here, it's 2, because of course our production environment is clustered, and it uses a larger amount of memory, or it's able to use a larger amount of memory. So talking about Terraform and Terraform files, I don't know if you know Terraform, but Terraform is getting, or is the standard to really define resources and configurations for cloud provisioning across different providers. So for example, AWS or Google Cloud or Azure does deliver plugins for Terraform to really automate the resource creation inside of the cloud provider. So here, for example, you can see we're defining a virtual private network, which is like the container for all of our cloud resources inside of AWS. Also, IP configurations and rules which components are able to talk with each other are built into Terraform and again are fully transparent. Here you can see we are also defining our elastic Kubernetes cluster. So what name does our cluster get? Also in which subnets and which regions should this cluster be created? Which can of course also be injected from the outside. So if we want to create, for example, a cluster in Oregon or infrastructure in Oregon, we just execute the script, adding some other variables, and then our whole environment gets created in Oregon or South America, or wherever we want to go. And additionally, we are also defining really the nodes we want to use, so the size of the machines we want to have below this, and if it's scalable or not. So we are also defining should the cluster scale automatically as soon as it sees that the resources are used up, or we need more power to build. So that was our journey with Kuberay, Liferay and Kubernetes in the cloud. I learned yesterday that in the last 2 years I did the same work as Liferay, more or less, because we also built Liferay on Kubernetes in a cloud provider. From the technology stack, it's very, very similar. What I really like about this is, on the one hand, really the flexibility. So if your business decides, oh, we need a new environment to showcase, or we want to do a Liferay migration, so you set up a new environment, you're able to freely work on that. And if everything is functioning as you're expecting, you're merging it together and you go ahead with it. This is really, really nice and very good. Also, we are able to run multiple instances. So at times we had 5 or 6 Liferay installations running for development perspectives on one cluster, which is also really, really cool and saves some money regarding resources you need. So yeah, that was my presentation. Thank you very much. I guess we have 4 minutes left, so if you have some questions now, I'm happy to answer them. Otherwise, I will be on the booth the whole day. And yeah, thank you. Can we get a mic?
Hi. Oh, yeah.
Thank you.
Hi. I have a question about the slides where you have the big picture. What is inside the package with the modules? You have all the modules, the custom modules for Liferay, what you built, or it's like split down in, let's say, for each module or group of modules, you have a different image?
No, at the moment we have like really all of the modules in one image. So it's like a zip of all the modules we are creating, the custom modules. If we need, for example, for the commerce installation, we have also some extensions which are coming from Liferay directly. So those get integrated into the image at the Liferay bundle. So for example, if I want to use multiple different providers for images and plugins, I would probably build it into the bundle. Into the Liferay image. At the moment, I'm building this image, so there will be a nexus, and I'm downloading those modules additionally while I'm building those images. So we do have like one image for all of the modules and bundles.
Hi. I have 2 questions. The first one, at what time do you build the modules? Do you build them like your custom modules? When do you build them? When you build the image, like the jars?
Okay, the job. Yeah, it's after all the modules are built, the tests are run, and all of the stuff. After this is finished, it's the same. It's essentially the same Jenkins job which builds the modules, which builds the image.
Okay. My second question was about patches. Do you modify your image every time there is a fix pack?
Yes.
Okay.
We're rebuilding our base image and advancing the version, and then we are testing the base image, also the combination between base image and modules to check if the patches are working. There's a full test cycle run on the one hand, of course, automated testing, and on the other hand, manual testing to make really sure that the patch is working and that those things are really functioning together. And if it's working, it gets integrated in the real development cycle and gets rolled out.
Okay. I have a third one, sorry.
I guess that's
what
the
about,
last one as well.
Like with clustering, you cannot start the different instances at the same time. We had these issues when using Docker Swarm. I know that Louis Guillaume just built a health check to wait for. Do you have something like that to wait that the first instance is started before starting the second one?
Yeah, we're even stopping only one instance. So that's as I said, we need, or we have the requirement to have the system running as much as possible, which is of course not the case if we are doing a Liferay update, but it's, we're using health check and readiness checks for this, which are provided by Kubernetes to directly see, okay, the node is now there, the license is there, and users are able to access those nodes. And only if this is finished, the second one gets shut down and get rebooted.